Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Technically Explained. In this video, we are going to discuss the basics of microwave CST Studio. So I am using the microwave CST 2017 version. If you are using the older or the newer model of CST, doesn't matter. There is not much difference between the older and the newer versions of CST. So when I open up my CST stands for Computer Simulation Technology. So when I open up my CST, when I click on CST, I have this type of window appear. And in the bottom, I have 6 different modules. You might have different numbers of modules depending upon your year of version. So I have 6 different modules, and when I move my cursor on each of these modules, brief information about each module is given on the right. So if when I move my cursor, brief information is given on the right. And on this right side, left to this module information, I have some recent files that I have designed and simulated recently. I have some project templates also, but if I want to design something new, I need to click on new template. So we will go on and click on new template. When I click on new template, I have different fields appear. We have the microwave and radio frequency and optical. We have the EDA electronics. We have the EMC, EMI, and then we have some charged particle dynamics, and then we have statics and low frequency. Of course, we are not concerned with statics and low frequency, neither we are concerned with charged particle dynamics, and neither we are concerned with something electronics. Now what is this EMC and EMI? This is actually electromagnetic compatibility or electromagnetic interference testing. And the basic idea is that all consumer goods such as the microwave ovens, the cellular phones, the laptops and satellite TV must perform the electromagnetic compatibility or electromagnetic interference testing to ensure that they do not cause harmful interference. But we are not concerned with that. We are not trying to figure out the electromagnetic interference test of microwave oven or cellular phone or laptop. We are concerned with microwave and radio frequency and optical. And I have told you in my introduction to antenna first video about the electromagnetic spectrum. So we know that where the microwave and radio frequency and optical, which is in the visible range, lies. So I'm going to click on the microwave and radio frequency and optical region. When I click on the microwave and radio frequency and optical field, now I need to select a subfield. Again, if I'm concerned, if I want to design periodic structure, I'm going to click on periodic structure. For example, if I want to design a metamaterial based periodic structure or a metamaterial based frequency selective surface, I need to click on periodic structure. If I am interested in the visible range, in the optical range, I have to select the optical applications. And if I'm selected in the variable antennas, if I'm interested in the variable antennas, if I'm interested in the specific absorption rate, which is the SIR, I'm going to select this. If I'm interested in the radar cross section, I'm going to select this. If I'm simulating any circuits, I can select the circuits and components in the microwave region. Though we have some diodes and FETs and some transistors in microwave region, if I want to simulate them, I can select this. But at the moment I'm interested in antennas, so we will go on and click on antennas. When I click on antenna, I need to click on next. After clicking on next, again I have some options of workflow. If I want to simulate a waveguide, I can simply click here. If I want to simulate a patch antenna, a planar antenna, I can click on this. And then we have the wire, the phased array options, mobile phone, reflector, dielectric resonator, radio frequency interference detector. But at the moment I want to select this planar or the patch antenna. So I'm going to select next. Next they want me to select the solver. it's not appropriate to talk about the difference between the time domain solver and frequency domain solver at this beginning stage. But there are certain pros and cons of both the solvers, especially when you are talking about the unit cell design, when you are talking about the periodic structures. But fortunately or luckily, when we are talking about the antennas, there is not much difference between the time domain and frequency domain, though there are certain pros and cons. But the time domain and frequency domain will give you, both the solvers will give you more or less the same results. So for now on, I am going to select the time domain uh, solver. Next we need to select some dimensions. For example, for the unit of dimensions, I can select millimeter, I can select centimeter, etc. I have different options available. For the unit of frequency, I can select gigahertz, I can select terahertz, hertz, kilohertz, etc. Similarly, for temperature, voltage, etc. I can always change these units when I am in CST Studio. So for now on, I'm going to simply click on next, and then they ask me what is my minimum and maximum frequency range. Again, depends upon my application. If I'm designing an antenna in the 5G range, I need to give a range, for example, from 20 gigahertz to like 50 gigahertz. If I'm here to design an antenna at 28 gigahertz and 38 gigahertz, I'm going to give range in 20 gigahertz to 50 gigahertz. And the field monitors, I also need to take the field monitors of my interest. uh, One thing about the field monitors is that if you select uh, all the field monitors, and if you give a very high frequency range, the simulation time will be more. So depending upon your time, you should select your frequency range, and of course depending upon your interest. And you can always change this frequency range whenever you like. So I'm going to simply give it a 10 gigahertz to, for example, 20 gigahertz, and then select, I'm going to select the electric field and the far field, and this at this specific frequencies, and I'm going to select next. After this is now going to tell me that what I have selected. I have selected the microwave and RF and optical, and in that subfield I have selected antennas. Then I have in antennas I have selected the planar antennas, and then I have selected time domain solver, and then I have selected the units and settings. So when all good to go, I am going to click on finish. As soon as I click on finish, the CST environment is going to appear. Now as you can have a look on the left side, there is a navigation tree. This is there, it is written the navigation tree. So we have a navigation tree over here. So we have navigation tree over here, which basically contains the simulation results of our model. So whatever we have designed a model here, we will have a simulation results here. So we can have all these results here, especially in the 1D results, in the 2D and 3D results, in the far field results. We can see the results over here. This is my workspace. All the components of my workspace will be here. This is my project title, which is untitled at this time. This is my workspace. This whole is my workspace, and this is my working plane. This grid is actually a rectangular coordinate system, and we have a rectangular coordinates here. And then at the below, I have the 3D and the schematic. So the 3D is my this plane, and then the schematic is another plane which is like this. So we are more interested in the 3D. Then I have some messages over here. So if there are any warnings, if there are errors, they will appear over here when I am simulating. And then I have the progress. For example, when I am simulating, I will see the progress, the parameter list, the parameters that I have designed in my model, and the messages that I get. So this was all about the environment. On the upper side, we have the toolbar. In the toolbar, we have different options like home, modeling, simulation, post processing, and view. In the home tab, I have these options of delete, which is basically used to delete a model. Because I don't have a model over here now, I have designed nothing over here. That's why the delete, the copy, the paste options are not available. And I can copy the view of this design. And again, I have these units. I can change the dimension units as I want. So at the start I have selected dimensions as millimeter wave, but I can change the dimensions from here, and similarly I can change the units of frequency from here. If I want it to be in megahertz, I can change it in the megahertz. Next, I have the problem type. So basically in the microwave, when we are designing antennas, we are basically concerned with high frequency. We are not designing any cable or any low frequency element, and thermal and mechanics are not even the matter of our concern because they are related to some mechanical engineering. So that's why in the problem type usually we will select the high frequency. And then we have the setup solver, again the time domain and the frequency domain solver. We have the eigen mode solver, integral equation solver, asymptotic solver, and multi-layer solver. For antenna designing, again time domain and frequency domain are very important. Both have certain pros and cons, but when it comes to antenna, the pros and cons are not that accentuated. When it comes to periodic structure, the pros and cons are more accentuated, and you have to be very vigilant selecting uh, the time domain solver or the frequency domain solver. And then we can start the simulation from here. If we have certain design, we can simply start the simulation from here. With the simulation, to the right side of the simulation we have the optimizer, which is a very intelligent tool. It optimizes our model or our designing to give us the better results. This is a very important tool. And the other important tool is the parametric sweep. So if you want to, for example, you want to see the results of your antenna for different dimensions. For 1 centimeter, for example, you want to design the page for 1 centimeter, for the feed line of width 1 centimeter, and then of 2 centimeter, and then of 3 centimeters, and you can perform the parametric sweep. The parametric sweep will give the results of all those dimensions in a single figure. So that's very important, and from that dimension you can you can confirm that which results are better. You can see that which results are better, and then you design the antenna according to those results. We have the mesh view. We can have a for mesh view we have different types of properties here, but for now I am going to again go to the mesh view. Again, in global properties I can change the max type. Here I have only hexagonal by default. I can select the hexagonal TLM and the hexagonal legacy, and then I have some other properties. I have the history list. History list will contain all the operations that I have performed. All the steps that I have performed will be given in this history list, and I can always delete or edit those steps from the history list. So this is also very important. I am going to close it from now. And then we have the calculator. If I want to perform something, if I want to perform some calculation, I can perform it over here. Then we have the parameters. All the parameters that we have, we can add them to there. And then we have the macros, which has options like calculate, construct, file, matching circuits, etc. So this was all about the home tab. And then we have this let me close this mesh view so that we can return to our home view. And then we have the modeling. On the left side we have the import export option. We can import models from different other softwares like the HFSS, which is high frequency structure simulator, which is also used for designing antennas. So you can import models from there. We can also export files from here. So that's a very useful feature to have in CST, to import and export files. Other thing is that you can select a background. So if you want to select a background, you can select a background over here. You can select materials from the material library. CST has material library and it contains many elements. For example, if you want to load something from the material library, for example, I want to load the FR4 substrate. So simply I'm going to search for FR4, and here we go. We will have different. Here we go. We have the FR4 lossy substrate appear. So all of these materials, they are already present in material library, and I can load them. So by clicking on load, that material will be loaded, but I am not going to load any material now because this is the basic tutorial about CST. And I can also design a new material and add it to the library. On the right side we have different shapes, like we have the brick, we have the sphere, we have the cone, we have the torus, cylindrical, and then some uh, operations that can be performed on these shapes. For example, extrusions, faces in apertures, wire for curve, etc. So this operations and these transform, blend, boolean operations, they are very important when you are modeling a design. When you are modeling an antenna or a patch antenna, microstrip antenna, they are very important, because for a rectangular patch you should select a brick and you can design it over here. We will see in our future videos, inshallah. Then we have the transform options, align options, blend options. These options are again not available now because I haven't designed anything. If I design anything, these options will appear. And I also have boolean operations, add, subtract, intersect, which are also very important. Then I have different types of curves. I have also picks where I can pick the faces of certain surface and select the middle of the surface. For example, I can select the edge of the surface, I can select the middle of the surface. So that's this space are very important, and from there I can pick the point. I'm not going to pick any point. For example, I can pick the edge center, I can pick the end point of certain surface, I can pick the center point, I can pick the point on a circle, and different options are available here. And then I have these properties, I have this history list again, and I have this, and I also have this local WCS whose coordinates are U, V and W. This is the global coordinate and this is the local coordinate. So I can always have the local coordinates, and I have this version here. If you can have a look, U, V, W, these are the local coordinates. They are also very helpful in designing, in modeling your design. Then we have the cutting plan, and that's it. And then the simulation, we have the frequency. Again, the minimum and maximum frequency can always be changed. If you remember, in the start we selected the minimum frequency to be 10 and maximum to be 20 gigahertz, but I can always change it from here, and I can always change background from here. And the boundaries condition, whenever we are designing something, we also need to define the boundary condition. How to define it, it's another theory, we will discuss it some other day. Then we have the waveguide port, discrete port, the plane wave, lumped element. All these are the input sources to be fed. If you are using the feed line, we use some waveguide port to be fed to the antenna. So these are the input sources to the antenna or any other structure. And then we have the field monitor, in which we have different options like the electric field, the magnetic field, the far field. We can select the specific frequency, and we can select different types. For example, we can select the surface current to know the surface current distribution, the current density, etc. So all these can be selected, and these are the part of the simulation. And then we have the setup solver, again optimizer, parametric sweeper also available. So this was the overall about simulation. There is not much important, nothing more, anything more important is because we have already discussed these things. And then we have in the post processing, we have the import export option, and then we have the S parameters calculation. They can also be calculated from the 1D results. And we have the loss and Q factor. We have the result templates, where we can create a 0D or 1D template as a post processing step. And finally we have the option of view. So in view, I have view options. I can copy this view and paste it somewhere. I can export this as an image. If I have designed something, I can export this as an image. If I want to not show the axis, I can just simply click on it. If you can have a look, the axis has disappeared. And if I want the axis, the global coordinates to appear, I should click this check marks. Again, if I want the bounding box to disappear, as you can have a look, the bounding box has disappeared. And if I want the bounding box to appear, I can let it appear. And then we have the text and labels. We have this working plan. So this is, again, this is my working plan. This rectangular grid is my working plane. I can change the dimensions. I have the zoom option where I can zoom something. I have the pan option also where I can move something. I have the rotate option. I have the dynamic zoom option. And if your view is distorted, you can always go back to your original view by clicking on this reset view. This will go back to your default view. And then we have the axis scaling and cutting plane, and then we have the windows. Now in windows we can have different options. For example, all these are text. Why? Because we have this messages option, we have this parameter list. For example, if I unclick this navigation tree, this is going to disappear. I'm going to click on this and this is going to disappear. When I click on it again, it will going to appear. Again, if I want these messages to disappear, I can simply click on here. Now we have only progress and parameter list. And if I want to show it, we can. You can also unselect all of these if you want to. You want to have more space for your model, you can unselect these all. So you can have a look. Now we have extra space for our model, but usually I don't like this. I want everything to appear so that I can have a look at everything and know what's going on. So this was the brief overview of CST Microwave Studio. Inshallah, in coming lectures we will have more tutorials about this CST. Till then, thank you.